So we've done a lot of work in C. And C is a really cool language because it gives you the ability to dive really low level into your programs. We get to do things as really minute as manipulating individual bytes of memory. Recall that pointers really allow us that flexibility. But do we always need to have that fine-grained level of detail in our programs? Probably not, right? And if we're going to have a trade-off between being able to do really, really minute things and really, really big things that we don't have to think about, we don't have to implement these really big ideas if they're already built in for us, generally, if we're building big programs or big projects, we're probably going to err on the side of having more language stuff built in for us instead of having low-level stuff. And that's where PHP really comes in. Now, one of the reasons that we teach PHP in CS50 is that it's heavily inspired by C. And in fact, in my opinion, there are really two sort of progenitor languages that are very common nowadays. C and Lisp. And they're progenitor languages because every other modern programming language that has developed since then sort of is inspired by one or the other syntactically. PHP is very similar syntactically to C, whereas languages like Scheme, for example, which you may have heard of, is heavily inspired by a language called Lisp, which is an older language. So the reason we teach PHP in CS50 is that by knowing C as fundamentally as you do at this point, picking up PHP, which gives you the ability to do much higher level things than C does, it isn't that much of a hurdle because you already have the basic sort of idea of the syntax. C's been around for almost 45 years at this point. PHP's been around for about 20 years. And in that sort of 25 years in between, programmers determined that they would much rather have higher level abilities. And sort of the mistakes and struggles of the 20 years in between led to PHP and other modern languages. PHP is a great choice of language for software that where you need to do things that in C are actually complicated. So for example, working with strings in C is very complicated because, as we know, strings in C are really just arrays of characters. It's not a built-in data type. Or perhaps more fundamentally, something we didn't even cover in C, what if you need to do some computer networking? Right? C has the ability to do it, but it's so arcane and so difficult to actually do. Wouldn't it be nice if the language sort of had a built-in, easy way to implement networking? And PHP is a language that makes that or facilitates that quite a bit more. As I said, PHP is very heavily inspired by C. The syntax is very similar. And so it should hopefully make the transition from one to the other a little bit softer than some other languages might be. To start writing PHP, just open up a file with the .php file extension. Technically, this isn't actually required, but if you want things like syntax highlighting in IDE so that type names or variable names, functions, you know, the keywords of the language are highlighted in a specific color, you generally want to name your files with a particular file extension. So we've named our file with a .php extension, but then also with PHP, all the PHP code that we write in that file has to be enclosed in these PHP delimiters that we see here on the screen. Angle bracket question mark PHP to start. Then we write all of our PHP code that we want in between. And then question mark angle bracket to close. If we don't do this, well, what's going to happen? It's not going to crash. It's not going to really ruin our program, but it's not going to have the effect that we want. What's going to happen really is that when we try and run this program, everything not between those delimiters is going to be printed out verbatim. It's not going to actually execute the code. It's going to just print it out verbatim. Now, why is this the case? So C is what's known as a compiled language. You're probably familiar with the step of making your programs, turning the .c files and .h files into a single executable with make, in particular using Clang as our compiler. PHP, though, doesn't have this equivalent. PHP is what's called an interpreted language. And what does that mean? Well, it means that we don't have to convert our source code to zeros and ones beforehand. Rather, there's a program, which is also called PHP, that understands PHP and can sort of make it on the fly. That's not really exactly accurate, but it's a pretty good analogy of what's happening. It's interpreting those zeros and ones on the fly. And so if it doesn't know how to process something, if it doesn't know how to process PHP, you probably wanted to put that text in there, right? You probably wanted to put the code in there, even if it's not between PHP, the PHP delimiters. But so it's not going to delete it for you. It's just going to basically discard it. It's just going to print it out to the screen. This seems like it's a bad thing, but actually it's going to be a really good thing, as we'll see when we talk about PHP web development, because it means we can intersperse PHP and HTML, and we can use them together to create a more dynamic web page. But more on that in the video on PHP web development. So what is the syntax of PHP? That's what this video is all about. Let's talk about it. So to start out, variables. PHP variables exist. They're just two big differences from C. The first is that there's no type specifier. We don't have to say int, char, float, all that stuff. We don't have to do that anymore. PHP is a modern language. It can figure out what you're trying to do or make a best guess as to what you're trying to do. So that's pretty nice. The other thing is that all variable names have to start with a $sign. It's just something to get used to. It's a little weird because it's so that PHP can understand what's a variable and what's not. So every variable name starts with a $sign. So in C, we might say something like this, int x equals 54. We don't have to do that anymore in PHP. We can just say $x equals 54. And we could say, for example, in C, if we had pound included the cs50.h header file, we could say string phrase equals this is cs50. We don't have to do that in PHP, though. We can just say $phrase equals this is cs50. And in fact, string is now a built-in data type in PHP, or rather, PHP understands what a string is. It's separate from an array of characters like it is in C. All your favorite conditional statements from C are still available for you to use, so no big transition there. We can have if statements like this, if $y is less than 43, or $z equals 15, so that's pretty straightforward. We can have if and else. We can have if and else if. And notice something pretty nice here, and this is sort of one of those advantages of PHP versus C. Notice what function we're not using here. We're using equals equals to compare a variable, $name, to a string. We couldn't do that in C, right? We had to use a function called strcomp or strncomp or any of its sort of related cousins. And so already we sort of see these advantages. We don't have to do something as silly or perhaps unintuitive as call a function called strcomp. If I just want to test whether a value equals a string, I could just use equals equals like I could do anything else. So there's an advantage. Sometimes, by the way, you might see else if as one word, else if. And that's OK in PHP as well. So sometimes you might see that. It's not a typo. PHP actually understands else if. I don't know why they decided to implement that, but as we've seen many times throughout our videos so far, we programmers love it if we can do things quickly. So getting rid of that space is apparently a big advantage. So that's if and else if. We also have the ternary operator, recall question mark colon for really short form, if else or conditional branching. And apparently in this, what we're trying to do here is assign the variable $letter either true or false, depending on whether $var is an alphabetic character. So this is pretty similar to isAlpha that we're familiar with from C. This is sort of the equivalent in PHP. The function is apparently called ctype_alpha, but that's how we do it in PHP. So all this is going to be is if $var is a letter, $letter is true. If $var is not a letter, $letter is false. We also have switch statements still. We recall those from C as well. At the very top there, that's how we do something like getInt or getString. So PHP has that built in. We don't need the CS50 library anymore. We can just use the function readLine. And what that's going to do is print out the message, your state please, and then blinking prompt waiting for the user to input some information. Now notice what else we can do with switch. If you've used it before, you may recall that switch is limited pretty much to integers and characters, but now we can use strings. And in fact, the switch statement in PHP is quite a bit more flexible than its cousin from C. Loops, just like conditionals, all of your old favorites are still there. We have while loops that count from 1 to 100 in this case. We have do while loops that count from 1 to 100. And we have for loops that count from 1 to 100. So no big leap there. The syntax is pretty much exactly the same, except now we're using $variable instead of declaring integer variables or something like that for our counters. Here's where things get a lot better than C, though. Arrays. So recall when we were talking about C, in order for us to grow and shrink sets of information, we needed to sort of default to this idea of a linked list, because C arrays were fixed in size. We couldn't shrink them. We couldn't grow them. We had to reallocate memory and do all this madness, or use linked lists, which take up quite a bit more space. But in PHP, arrays are not fixed in size anymore. They can grow and they can shrink. So again, these sort of 20 years that existed between the first release of C and the first release of PHP, we decided, it would be really great if we could do this. And so we implemented this. So PHP arrays are not fixed in size, and because PHP doesn't really have programmer front-facing notions of types, we can mix data types in our arrays too. So we don't even have to use all integers or all floating points. We can have a mix of all different kinds in a single array. Declaring an array is pretty straightforward. Just like any other variable, $nums equals array 1, 2, 3, 4. Array being a function that's built into PHP that will create an array for you. This creates an array of 4 values, numbers in this case, called $nums. And there's more than one way to do it. And we're going to see this a lot in PHP. PHP has been developed by many different people and sort of grows and grows and grows. There's usually not just 2 or 3 ways to do something in PHP. There's usually like 10 or 20. Here's just another common way to declare an array. $nums equals square bracket 1, 2, 3, 4. So this is sort of similar to C's curly brace notation, rather. Or it would be int nums square brackets equals curly brace 1, 2, 3, 4. In PHP, it's $nums equals square brackets 1, 2, 3, 4. But both of these examples here give me an array of 4, in this case, integers. What if I want to tack something on now? Well, I can just say $nums 4, which again, we're still counting from 0 here in PHP, would be the 5th element of the array. I can just say that. I'm not going to suffer a seg fault because my array is just going to grow to accommodate that. It's pretty nice, right? And in fact, I don't even need to specify where I want to put it. I can just say this and just tack it right onto the end. Or I could even just say $nums 20 or 1,000. It doesn't really matter. It's still just going to tack it right on to the end. So I can grow, and as we're not going to cover it in here, but I can splice or strip elements out of the array as well, and the array will shrink to accommodate that now missing or empty space. There's another way to tack something onto an array, which is a function called array push. So again, there's this idea of being able to do things many different ways. So we've seen 3 different ways now to tack another element onto an array. So this adds another element to the end of the $nums array. And we can mix up our data types. So I could have an array of not 1, 2, 3, 4, but 1 true 3, 4, where true is a Boolean. And then if I want to tack on another element to that array, perhaps a string, the string FIVE, I could do that. And now my array would be 1, true, 3, 4, 5. The word 5, not the integer 5. So a lot of flexibility there. The flexibility gets even better, though, because PHP it has support for something called an associative array. And we sort of vaguely talked about associative arrays in C in the context of hash tables, because what associative arrays are really all about are making key-value pair mappings. And in this case, the keys, if we're familiar with arrays from C, the keys are index numbers, 0, 1, 2, 3, and the values are what we would find at array 0, array 1, array 2, and so on. So the keys are indexes, and the values are what is in that array location specified by that index. But in PHP, we don't have to do this notion of array 0, array 1, array 2 anymore. We can now use actual words to map keys to values. And so I could say something like this. I could create an array using the square bracket syntax as follows. $pizzas equals square bracket cheese, and then this sort of double arrow notation, $8.99, comma, pepperoni, arrow, $9.99, and so on. And so what's going on here? What am I actually doing? I'm creating key value pair mappings. So instead of saying, for example, pizzas 0, pizzas 1, pizzas 2, I can now say pizzas cheese, pizzas pepperoni, and refer to the values associated with them. So here are our keys in green: cheese, pepperoni, vegetable, buffalo chicken. Here is the arrow, so that sort of makes this key value pair mapping. And then here are the values at that array location. So it's like saying array 0 equals $8.99. The key is 0. The value is $8.99. I can now say array cheese, or in this case pizzas cheese. Cheese is the key, and what I find at pizzas cheese is $8.99. That's the value that I find there. So I can say things like this: $pizza cheese equals $7.99. Say I'm having a sale. I want to drop the price of the cheese pizza. Or I can use the vegetable pizza as part of a condition. Or I can add a new element to my array, just like I could do previously. I can add a new element to this associative array with the key bacon and the value $13.49. But this sort of introduces a problem if you think about it for a second. how would we iterate through this array? Right? In C, we would just have a for loop typically that would run from 0 to the size of the array minus 1. If the array has n elements in it, the valid indexes are 0 to n minus 1. So we could use a for loop to sort of step through every single element. But that's not really the case anymore, right? Now we have key-value pair mappings where the keys are words. How do we iterate over all of the words? Well, fortunately, PHP has a way to deal with this too, and so we'll jump back to loops for a second to introduce a fourth kind of loop that exists in PHP called a for each loop. And what a for each loop does is it's basically the same idea. You can use it for any kind of array, but it's basically the same idea as a for loop, except instead of using index numbers, you just have this weird syntax where you call every single element a name for the purposes of this loop. So in this case, for each $array as $key. Basically, as that comment notes, inside of that for each loop, it's going to go over every single element of $array, which is typically going to be an associative array, but can really be any kind of array that you want in PHP. And every time that in a for loop you might have said $array square brackets $I, you can just say $key. So that $key becomes an alias for every index of your PHP associative array. And so you can use it like that. So for example, we've now got our pizzas array. I've kind of tucked it into the corner there so we can use it to do a quick example. If I say for each $pizzas as $pizza, well, what's happening? Well, I'm going to iterate through every single element of the array $pizzas. And in so doing, I'm going to call every element when I'm inside of the body of that for loop $pizza. So that's sort of a stand-in, recall. That $pizza is a stand-in for saying $pizzas square brackets $I if we were using a for loop where we could go from $I equals 0 to, in this case, $I equals 3. If we didn't have key value pairs here, this would be element 0, 1, 2, 3, and we would use a for loop to go $pizzas 0, $pizzas 1, $pizzas 2, $pizzas 3. So now just $pizza is substituting for that individual key. So what is this going to print out? I'm printing out $pizza. What am I going to find if I print out $pizzas $I, right? If I'm going to print out the ith element of pizzas, what am I going to print? I'm going to print out the values at that location, right? Like if we were doing this in the context of C, we don't usually use our iterator variable int I equals 0, I is less than 3, I++, to print out 0, 1, 2, 3. We're printing out array 0, array 1, array 2, array 3. And so what this prints out is this. It's the list of prices, $8.99, $9.99, $10.99, $11.99. Now, a quick note here, a for each loop does not necessarily print out things in order. It's not guaranteed. It usually does. It's usually based on the order in which elements are added to the array. So just bear that in mind. It might not be in order. But a for each loop will iterate across every single element of the array in question. In this case, again, that array is $pizzas. I can change the syntax, though, if I want both the key and the value. Instead of saying $pizzas as $pizza, I can sort of say this, and if you look at what I've highlighted in green here, it looks like a key-value pair mapping. And so even if you are not entirely sure what it's going to do, you can probably guess that $topping is going to be the key in this case, and $price is going to be the value. So I'm substituting now every element of $pizzas as a key-value pair, and now I can refer to the key and the value, which might come in handy, for example, as follows. A whole, so there's a lot of printing going on here. A whole topping pizza costs price, and then I print out a period and a \n. So now notice, again, I have access to a key, $topping, and a value, $price. So can you guess what this is going to print out? There's a lot of print statements, but there's only one \n, so it's going to print something on a single line of code. If I can refer to the key and the value, then now instead of just being able to print out the prices, I can print out something like this. A whole cheese pizza costs $8.99, and now I'm using all of the keys, cheese, pepperoni, vegetable, buffalo chicken, and the values, $8.99, $9.99, $10.99, $11.99. So that's just a different way to do a for each loop, that instead of just giving you access to the values, it gives you access to the keys and the values. So printing out information. I've already done it a couple of different ways, you might have noticed. The two functions we've primarily seen are print and echo. And for pretty much all intents and purposes, they're exactly the same. There's a very subtle difference that's not even worth getting into, but basically everywhere you can use print, you can probably use echo as well. And that's not the only two. PHP has a lot of different ways to print things out. And it also has ways to integrate variables into the middle of strings. So recall from C, do you remember what function we can use to substitute variables into things we want to print out? You probably use this function quite a lot, printf, right? So this is what we had before inside of the context of our for each loop. We had these 5 separate print statements, because that was the only way I really knew at the time how to print out messages. I didn't know how to integrate the variable $topping into my PHP code. Well, if I had just taken a wild guess, printf, it actually would have worked. Printf is a function that I can use in PHP, just like I can use it in C. And so something like this, printf, again, we're familiar with that. The first %s is replaced with the value of $topping. The second %s is replaced with the value of $price. And so I'm interpolating, which is just a fancy way of saying I'm sticking the variables into that location. So I'm plugging in $topping where the red %s is, and $price where the blue %s is, and then I would get the message, a whole cheese pizza costs $8.99. Not the only way I can do it, though. Maybe I would want to use this method. This is actually what's most commonly called variable interpolation. I can use an echo. I could use a print too, as we'll see. But what's happening here? First of all, I have to escape the $sign. Because remember, when we were actually printing out the prices of the pizzas, I was actually formatting them as monetary figures with a $sign. But we're using $signs also to represent variable names in PHP. And in particular, when I'm using this method of the curly brace variable interpolation method, I need to escape my $sign so it doesn't think I'm talking about a variable. It's going to actually literally print a $sign. So sort of analogize it to what you see at the end there. It doesn't actually print \n, right? It prints out a new line character. It's not going to print \$. It's going to print out just a $sign character. Same idea. Escape sequence is what these things are called. But notice that I am not doing any sort of %s substitutions. I'm just literally plugging in these variables. And so in this, what would happen here is that the value of $topping, again, just keeping with what we've been talking about so far, cheese, would get plugged in there. And $price would be whatever value is at pizzas, square brackets, cheese, which was $8.99. And so this would also print out a whole cheese pizza costs $8.99. And like I said, I could use print here instead of echo, and the functionality would be pretty much exactly the same. It would print out the same thing. There's another way to do it, and this is another advantage of PHP working with strings. We can do string concatenation. We could do this in C too using a function called strcat, but again, we had to call separate functions. It was this whole mess to do it. We had to pound include string.h. It was a production, right? But now I can just use this dot operator to concatenate strings together. So I'm concatenating a whole, and then whatever the value of $topping is, and then another string, pizza costs $, and then concatenating whatever the value of $price is, and then at the very end I'm tacking on period \n. And so this would also print out a whole, again, if we're talking about the first element of that pizzas array, a whole cheese pizza costs $8.99 period \n. Again, with the $topping and $price substituting for what we had specified in our for each loop as the key value pair mapping. PHP can handle functions. Functions were sort of integral to C, as we saw. Like variables, we don't need to specify the return type of the function because it doesn't really matter. And we don't need to specify the data types of any parameters because they don't really matter, like we've seen in PHP. Every function is introduced with the function keyword. That's how we indicate to PHP that what we're talking about is a function. And we don't have to deal with main at all because the interpreter, the PHP interpreter, works from top to bottom, regardless. If it sees you make a function call, it'll go find the function call even if it comes later, but it's going to read from top to bottom, so we don't need to specify here's where you start. You start on line 1 of your PHP and work down from there. So here is how I would create a function called hard square that apparently takes one parameter, which I'm calling $x. This function is complicated just to illustrate various things. We still have return values. I'm using a for loop here, but it's basically just what this amounts to is just $x times $x. What I'm actually doing is just adding x to 0 x times, or $x to 0 $x times. But it is effectively exactly the same as multiplying $x times $x. I can still return a value, in this case $result, and I've made a function in PHP. Here's how I might use it in context. So maybe I'm inside of some PHP file. Notice in blue there that I've used my PHP delimiters, angle bracket question mark PHP. In between those are all of the PHP that I want to write. So I'm apparently going to I'm going to prompt the user to give me a number, store in that variable $x, whatever they gave me. Then I'm going to echo hard square of that value, and I'm apparently going to tack on a new line as well. And then later on, I'll define the function hard square so that when I make the call to hard square, it knows what I'm talking about. Now, I could also do something like this. This is slightly different. It's almost exactly the same as what we saw before, except instead of saying just $x there as the parameter to hard square, I'm saying $x equals 10. So this is an example of defensive programming, guarding your programs against malicious users. This is one way to do some error checking that we didn't really have as an option in C. We can never specify the default value of something. We always had to check whether for example, if we made a call to getString, it was most proper if immediately after we checked that, we checked whether the string that the user gave us is not equal to null, because we don't want to start working with a null string. Here, this is a way to guard against that. If the user doesn't provide us something somehow, what are we going to do? Well, we'll just say whatever they didn't provide us, we're just going to plug in 10 instead. So if they didn't give us a value, just use 10 by default. And so here, notice that I'm making a call to hard square, but there's no prompt to the user, right? I'm just making an empty call. But my function hard square is expecting a parameter. What is this going to print out? Well, it's going to print out 100, right? Because the user didn't give me anything. And so I'm just going to assume that 10 is the default value, and so this would print out 100 on its own line. PHP files do not have to be just a single file. You can combine multiple files together just like you can in C. The way we did that in C was typically to do a #include to get header files pulled in. We don't do that in PHP. We do something called require once. And then there's this whole thing. What's this __dir __? That's just a special variable, or special constant really, that specifies what your current directory is. And so it's going to look in your current directory for a file called cs50.php in this example here, and it's going to stick that file at the top of your PHP program, assuming that you put the require once line at the top of your PHP file. So PHP is primarily used, but not exclusively used, as a language for web-based programming. That's really how it sort of came to be. But it is a full language, as we've seen. We've seen pretty much all the things that it can do that are similar to C, and it can do a heck of a lot more than that. But because it's a full language and we can do command line programming in it, we can run command line programs. All that's required to run a command line program that's written in PHP is that you have a PHP interpreter. So it's sort of analogous to having a compiler on your system. If you want to compile your C code to turn it into executable files, you need to have a PHP interpreter that exists on your system so that you can interpret PHP files. Assuming you do, and usually this interpreter is called PHP, and it's usually bundled with most downloads or installations of PHP that you can get online, and it's certainly the name of the PHP interpreter we have in CS50 IDE. All you do is type PHP file. And what your program's going to do is it's going to run through the interpreter. It's going to ignore everything that's not in between question mark or angle bracket question mark PHP, the PHP delimiters, and print it out, and it will interpret and execute the code inside of your PHP delimiters. So let's pop over to CS50 IDE and have a look at a couple of PHP files, running a couple of PHP files in the command line interface of CS50 IDE. So here we are in CS50 IDE, and I've taken the liberty of opening a file called hello1.php. And apparently the contents of this file are just the PHP delimiters there, and in between, echo hello world. This is a pretty simple PHP program. I'm just going to scroll down to my terminal window here, and I'm going to type php hello1.php, hit enter, hello world. That's probably what we were expecting it to do, right? Let's go up and take another look at a program. hello2.php. Pretty much the same thing, not a lot going on here. This time, though, I'm going to prompt the user to give me their name. So I'm using that readLine function again. $name equals readLine. That's the prompt. What is your name? Apparently, I'm printing it on its own line. And then, so the line below that will be the prompt where the user can enter their name. And then I'm using a little bit of variable interpolation here on line 3 to print out hello and whatever the user typed. So if this is analogous to saying hello, comma, %s if we were using printf and C. So let's go and interpret this program. So again, I'll scroll down to my terminal window, php, hello2.php. What is your name? Doug. Hello, Doug. I also have another file called hello3.php. I'm going to clear my screen with Control L, and I'm going to execute that. What is your name? Doug. Hello, Doug. So the behavior is identical to hello2.php, but why is it hello3.php? Well, here's the difference. In this case, notice that on line 1 here, I have something that's not in between the PHP delimiters. I'm just printing out, or I just typed, what is your name? When the PHP interpreter sees this, it has no idea how to interpret it as PHP, and so instead of failing, it's just going to spit it out. So notice on line 3 now, my call to readLine, there's no prompt anymore. I'm just actually going to, when the PHP interpreter sees this, it's going to print out what is your name. Then it sees, oh, OK, here's everything else is going to be interpreted as PHP. So that's why this works. I don't have to necessarily prompt the user to, inside of readLine, I can just have it outside of the PHP delimiters and allow the interpreter to just print it out for me. So you don't actually only have to have one set of PHP delimiters in your program. You can actually have several of them, opening and closing them as needed. So let's take a look at a couple of programs in CS50 IDE where we illustrate this idea of having multiple sets of delimited PHP. OK, so I've opened a file here called add1.php. Notice what's happening here. Just as before, I have a single PHP set of delimiters. I'm going to print out the message, please give me a number. Then I'm going to read a line and store it in the variable $num1. Then I'm going to print out again, give me a second number, read a line from the user, store whatever they typed in $num2, add them together and store that result in a variable called $sum, and then print out the sum of these two numbers is, and then interpolate there the variable $sum. So let's just run this through the interpreter to confirm that this is what we expect. PHP add1.php. Please give me a number 3. Please give me a second number 4. The sum of these two numbers is 7. That's 3 plus 4. OK, so nothing terribly fancy there. But now let's open up add2.php. Here, I've got a couple of PHP delimited sets there, right? Lines 1 and 3 have no PHP delimiters. So when the interpreter sees them, it's just going to spit out exactly what I have typed there. So that's what I'm doing on my prompting. On lines 2 and 4, we see the very familiar $?PHP sort of delimiters. So those two lines are going to execute as PHP. And then on line 5, I have this weird thing right here, right? This angle bracket question mark equal sign. I'll even zoom in a little bit further so you can see this is what I'm talking about right there. This $question mark equal sign. It turns out that it's so common that the reason that we open up a set of PHP delimiters is to print out a value. And that's all we're going to do, that there's even shorthand for that. $question mark equal sign is PHP shorthand for saying something like $question mark PHP echo the sum of num1 and num2. So this is just another shorthand for that. So if I run this program, php add2.php, and I'll zoom down a little bit, please give me a number, 4. Please give me a second number. And since I don't really care about data types in PHP, I can say 4.8. The sum of these two numbers is 8.8. That function behaves pretty much exactly the same as we would expect as well. And I have one more open up here called dice.php. Try this again. And I have one more here called dice1.php, which also has that angle bracket question mark equal sign notation in there. But notice that in this case, I'm calling a function rand, which, as you might expect, generates a random number. You rolled a, and it's going to calculate some random number, mod 6 plus 1. So that'll give me a number in the range of 1 to 6. remember that mod 6 would give me a number in the range of 0 to 5. But if I'm simulating dice rolls, which is probably what I'm doing here, I don't want dice that go from 0 to 5. I want dice that go from 1 to 6. And so this is a way to get me in the range of 1 to 6. And I'm doing this twice. So apparently I am rolling 2 dice in this program. So I'll clear my screen, and I'll do php dice1.php. You rolled a 4 and a 2. And if I run the program again, you rolled a 5 and a 5. So every time I run the program, I'm getting different numbers, because every time I do so, it's starting over. It's going to generate a new set of random numbers for me. So if we're used to running programs from C, we're used to typing // the name of a program, right? That's how we've done all of our programs in C so far. We can do this in PHP as well by adding something called a shebang to the top of our PHP files. I know it's kind of a silly word. It's short for hash bang. That's the first 2 characters there. Remember, we call exclamation point frequently a bang in computer science. It also might be for sharp bang. There's a couple ways to interpret it. But it's basically a special sort of command that the PHP interpreter understands as, oh, I want you to execute this program, which is apparently /users/bin/php, which is actually where the PHP interpreter specifically lives on our system. So what happens here is the interpreter understands, oh, I'm apparently supposed to use this program to run this file. And so it allows you to skip over the step of having to say php something.php. There's one other catch here, which is that if we want our programs to work as expected, we need to do something called a file permission change. And we'll go and we talk a little bit more about file permission changes in our video on MVC. But suffice it to say that this is what you need to do in order to make your .php files executable. So let's take a look at this as our final example over in CS50 IDE. So here in IDE, I have 2 files in this PHP directory that appear not to be called .php. I have a function called add. I have a file called add3 and a file called dice2. So let's take a quick look and open up add3. And as you can see, at the beginning of my file, I have this shebang, right? This hash mark exclamation point. Now, you'll also maybe notice that for some reason, I don't have any syntax highlighting anymore. And this is what I alluded to earlier, which is that if I don't name my file .php, I don't have the benefit of syntax highlighting anymore. This file is just called add3, so that I can run it later on with /add3 and not /add3.php. So the reason it's still fine, it's still valid PHP, but it's not syntax highlighted because this file is not called something.php. That's the only real difference here, plus the shebang. So let's see what happens when I try and run this program, /add3, just like I would with C. Bash /add3 permission denied. This is what you're going to see if you forget to use the chmod command to change the permissions of the file. As it turns out, regular PHP files cannot just be executed. They can be interpreted, but we're doing something a little different here. We're executing it. And so I need to add the permission of execution, chmod a plus x to add3. Then I can say /add3, please give me a number, 5, 6. The sum of these 2 numbers is 11. Similarly, I have already chmodded dice2. So I can just type /dice2. You rolled a 1 and a 1. You rolled a 5 and a 4, and so on. So that's pretty much the idea with PHP syntax, right? There's a lot to get through, I know, but hopefully you see now that PHP is not really that different from C, and really it gives us the ability to take things up a notch or 2. We don't really have to worry too much about the low-level details that we had to worry about with C, right? We can focus on the higher-level stuff that PHP allows us to do and sort of take for granted that it will work for us. So it gives us the ability now, transitioning from C to PHP, to make programs that are a lot more complex and perhaps a lot more robust. So I hope you have fun working with PHP. And I'm Doug Lloyd. This is CS50.